Now, the natural sciences are a big challenge. Some people say that we don't need Kalam for the natural sciences because the natural sciences are self-sufficient, and all Kalam can do is, for every generation, as the natural sciences develop, we need to answer the challenges of the natural sciences, as if the natural sciences are normative and we have to kind of run in order to catch up with the natural sciences. This is actually quite misleading. Humanity has been able to develop the natural sciences to the extent that they have been developed because paradigms keep shifting. As Thomas Kuhn, in his famous book on scientific revolutions, he actually articulates the fact that science actually works in bouts, periods of activity and research that are based upon a certain worldview or paradigm. But every once in a while, there would come a great visionary, a great thinker, a great physicist or naturalist who will actually change the very paradigm with which we work, and then a new physics develops. This has happened when we went from the Ptolemaic astronomy into the astronomy of Galileo and Kepler. It also happened when physics changed at the hands of Isaac Newton with his Principia Mathematica. It happened again when Einstein basically defied the Newtonian limits and began to talk about mass not as a constant but as a variable and developed the theory of relativity. It happened to us again when Heisenberg and others developed quantum physics. These shifts, these paradigm shifts, don't happen in the laboratory. They do not happen by deducting further propositions from the propositions we have from the existing science. They rely on new ways of envisioning. They rely on new ways of seeing, a new modes of experience of the world that then become articulated in hypotheses, which then become the basis for the design of experiments, and then experiments become implemented in laboratories, and then we have verification or falsification, and so forth. These visionary moments are the most significant in the history of science. And this is articulated in Thomas Kuhn's book on scientific revolutions, but it's also already in the works, the important works of Karl Popper in his work of 1934 on scientific discovery. It's also in the students of Popper, like Emry Lakatos, a magnificent thinker, a very important philosopher of science, who wrote about scientific research programs, in which he explained that every scientific research program has a hard core an essence or a center of propositions that are held almost as dogma. And then there is a softer shell of articulated hypotheses, which then become theories and propositions that are based on that. What happens? How do we get these basic propositions, and how does the shift happen between one age of science to another? This happens through human beings who are not limited by the science of their age. Human beings who reflect upon the grand questions of humanity. Who are we? Where do we come from? Where are we going? How do we live? These questions are grand questions. And these questions can be addressed by philosophy, but the mutakallimun can also address them from a religious point of view. Therefore, science itself can actually benefit from reading about the speculations of philosophers, like as in the cosmologies of Hegel or Schelling or Fichte or Vico or others. But it can also benefit from this, not only the speculations, but the articulations of great mutakallimun. You know, the books of Fakhruddin al-Razi, for example, including his tafsir, his exegesis of the Quran, include massive works on natural science that ask about the most intricate of questions that are actually quite important. Take as an example the question of emergence. Today, emergence is at the cutting edge of concepts. The physics of emergence, which is associated with the Santa Fe Institute and MIT and other advanced institutes, in which people are asking the question, what is emergence? This notion of emergence, I've looked at most of the important books on it today. None of them is as sophisticated as the speculations and the discussions and articulations of Fakhr al-Razi on emergence, or even Al-Qadi Abd Jabbar in Mughni has a whole volume on al-Tawallud, which is actually quite an intricate theory of emergence. The Ash'aris spoke about it as well, rejecting the Tawallud of the Mu'tazilis and so forth. So our treasure house of Kalam arguments and discussions can actually benefit scientists in finding new ways of thinking, so that we're not locked in the categories of understanding that the existing science fits us in. Therefore, if Muslim scientists and other scientists want to be creative and want to think about things in new ways, let them look at the amazing arguments about al-Jawhar al-Fard, or the atomism of the Ash'aris and the Mu'tazilites and others. Let them see what the ancient Kalam said about, for example, processes. What does it mean to have a arad? What does it mean to have an event? What is an event? What is the difference between an event and a thing? Today we say that light is either particles or waves, meaning either jawahir or a'rad in a way, to put it in the classical ways. What does it mean to be a process? What is a process? What is a field? You know, now today in thermodynamics or in Maxwell's equations, we speak about energy fields. What does it mean to have energy? What does that mean? You know, it's a Greek concept, energia, that comes from Aristotle, and it's been developed, but it's very difficult to say what energy truly is. What does it mean to be an event? What is an event? And what is temporality itself? These questions are not merely scientific. These questions are worked on by the philosophy of science, the philosophy of time, but also the kalam of time, the kalam of science, the kalam of nature and physical nature. What does it mean to have taba'i'? Are taba'i' inherent in things? Are the regularities and patterns we see, are they inherent in things, or are they divine dictates? And if they are divine dictates, is there consistency in them? Is this consistency based on self-commitment? Does it have an external reason? These questions are not irrelevant questions, and they can be of direct benefit to science. So not only do I encourage young Muslims to study science and the philosophy of science, but I also ask the naturalists and the scientists and the philosophers of science to be humble enough to understand that there are great articulations and the great speculations and the great visions of how to look at the world. So it's not a mere set of dead things, but a living, buzzing set of processes of divine manifestation or ayat that are active and actively affecting all of us, so that our life amongst these ayat is not simply studying a set of propositions, but engaging a living cosmos created and sustained by a living God. Thank you.